Doing better than Numpy'S in 1D mask function, ordered arrays. This operation needs to be applied as fast as possible as the actual arrays which contain millions of elements. This is a simple version of the problem. So, I have a random array of unique integers, normally millions of elements. Totalids equals 5, 4, 3, 1, 2, 9, 7, 6, 8. I have another array, normally a tens of thousands, of unique integers which I can create a mask. I can use Numpy to do. Mask equals np in 1d, totalids, subsampleids, assume underscore unique equals true. I can then extract the information I want of another array using the mask, say column 0 contains the one I want. Variable equals all variables, mask, colon, 0. Now given that the IDs are unique in both arrays, is there any way to speed this up significantly? It takes a long time to construct the mask for a few thousand points, subsampleids, matching against millions of IDs, totalids. I thought of going through it once and writing out a binary file of an index, to speed up future searches. Where X is in subsampleids. Then I can just do. Right? But this is also slow because there is a conditional in the loop to find when it first matches. Is there a faster way to find when a number first appears in an ordered array so the conditional doesn't slow the loop?
Often this kind of indexing is best performed using a DB with proper column indexing. Another idea is to sort totalids once, as a pre-processing stage, and implement your own version of in1d, which avoids sorting everything. The Numpy implementation of in1d, at least in the version that I have installed, is fairly simple, and should be easy to copy and modify. Edit. Or, even better, use bucket sort or radix sort. That should give you O, n plus m, n being the size of totalids, and m the size of sampleids, times a constant you can play with by changing the number of buckets. Here too, you can split totalids to buckets only once, which gives you a nifty O, n plus m1 plus m2 plus. Unfortunately, I'm not aware of a Numpy implementation, but I did find this URL.
I suggest you use data frame in pandas. The index of the data frame is the totalids, and you can select subsampleids by df.9 subsampleids. Create some test data first. Then convert udata into a data frame. Data frame use a hash table to map the index to its location. It's very fast.